Okay, 2012 AMC, this is problem 22 from the AMC10A, and it says the sum of the first m positive odd integers is 212 more than the sum of the first n positive even integers. What is the sum of all possible values of n? Okay, so the sum of the first m positive odd integers. Well, we know a formula. This is an arithmetic sequence with common difference 2. The first term in the sequence is going to be 1. The last one, so this is the first one, is going to be 2m minus 1. And then we multiply that by how many times we add the first and last term together, which is m over 2. And that should equal 212 more than, so 212 plus the sum of the first n positive even integers, which is going to be, the first one is 2, the last one is going to be 2n, and that's multiplied by n over 2. And if we reduce this down, we'll get m squared is equal to 212, and this last one is going to reduce down to plus n squared plus n. And this is actually where I got stuck. I thought about taking the discriminant here, but I didn't, and I had to go and look at the Art of Problem Solving forums, and that's where one of the solutions did that. And so let's do that here. We want to figure out what possible values of n satisfy this, so I'm going to do everything in yellow now. This is the same as the quadratic equation on the variable n, because that's what we want to find, possible values of n. N squared plus n plus, and then I have 212 minus m squared as my a is 1, b is 1, c is this term, equals 0. We'll do the discriminant on this. Okay, so the discriminant on this will be 1 squared minus, and this is part of the quadratic formula. We'll use that later to get the final answer. 1 squared minus 4 times a, which is 1, times c, which is 212, minus m squared. And the only way this can have integer solutions is if this is a positive perfect square. So we'll just call that k squared. And we'll do a little bit of algebra on this. So we get 1 minus, I'm going to distribute through and get 848 plus 4m squared is equal to k squared. And if I get the m squared and the k squared on one side, and now the 847, because 1 minus 848 is negative 847, I'll get to the equation 4m squared minus k squared is equal to 847. And this factors very easily. It's a difference of squares, so this is 2m plus k times 2m minus k. And that will be equal to 847, but 847 factors as 7 multiplied by 11 squared. And from here, we can actually figure out what k has to be, and then from there, we can figure out what n has to be. So the possible ways that this factors, so 847, let me write this in red. We're going to use this next. So 847 is equal to, oh, that's not an 847. 847 is equal to 1 multiplied by 847. Or I can use this to help me out. 7 multiplied by 11 squared, so 7 times 121. Or 7 times 11, which is 77 times 11, so or 11 times 77. Okay, and the only other possible ways to multiply is something like 77 times 11, 121 times 7, so these are all of the pairs. And what I can do is this. I can say, and I want positive k values. I could get the negative ones, we'll get the same answers out of it. But basically, if 2m plus k times 2m minus k, and they must both be integers, multiplies to be 847, then I have three choices. I have 2m, I'll make a positive k, so 2m plus k is the bigger value, equals 847, and 2m minus k is equal to 1, or I have 2m plus k is equal to 121, and 2m minus k is equal to 7, or the final one, 2m plus k is equal to 77, or 2m minus k is equal to 11. Okay, so these are the three possible ways that we can get this to work out, unless I made k negative, which I'm not going to. And from here, I'm going to solve the first one all the way out, and then we'll just sort of say the rest work the same way and get to the answers because it's going to take too long. But I will subtract the second equation from the first one. The 2m's cancel out. I get 2k is equal to 846, which means that k will equal 423. Same thing happens here. 2k will end up equaling, I'll just show it, what the heck. Okay, so those cancel. 2k is equal to 121 minus 7 is 114, which means that k equals 57. And this one, subtract the second equation from the first, you get 2k equals 66, so k is equal to 33. But this was the square root of the discriminant, and so what we can use from that is we know that the entire quadratic from this will give me n is equal to negative b, which is negative 1, plus or minus. I'm just going to do plus because I don't want any negative integers here, so plus square root of k squared, because k squared is a discriminant, so it's just going to be k all over 2, and if I put in 423, I get, I'll just jump to the answer. Put in 423, negative 1 plus 423 is 422, so divided by 2 gives me 211, or put in 57, we get 54, divided by 2, which gives me, we get 56 divided by 2, which gives me 28. And negative 1 plus 33 gives me 32, divided by 2 is 16. And we add those three together, and I get 255, which is the sum of all possible values of n, so the answer is A.